Hello friends. Welcome to T Academy. Now in this session, we will discuss the important questions asked in the previous GATE and the TNEB examination model questions. Now I am going to discuss a topic of the maximum power transfer capability in the power system. So the general formula for the power is P is equal to EV by X into sine delta. So now based on this formula, we are going to solve few questions here. Now it is the P. Now if you want a P maximum, for the P maximum will be happen when the delta sine delta is going to be 1. Okay, that means the load angle is going to be 90 degrees. And second case is when E is equal to V, excitation is equal to terminal voltage. So based on this assumption, if you follow, then you will say V square by F is the maximum power transfer capability. Now let's take the question here. An 800 kV transmission line has a maximum power transfer capacity of P. When operated at 400 kV with a series reactance unchanged, the new maximum power transfer capability is. So this is the maximum power transfer capability formula is P is equal to V square by X, which is operating at a voltage of how much? 800 kV whole square divided by X here. Now the new power handling capability is same formula only. So V square by X, but the second case voltage is 400 kV. So 400 kV whole square by X here. Now new power capability. So Pn by P is equal to, we'll get it as a 800 kV whole square divided by 400 kV whole square. So this, if you solve this here, it will be 1 by 4. So Pn is equal to, so P by 4 is the right answer for this question here. Okay, and one of you commented in my previous video that how to use a calculator, sir. Okay, but in the examination actually calculator is not allowed. Okay, so this is one of the best process that nowadays the examiners are following is to eliminate the candidates. Okay, so remember boys, remember this. So competition. In the competitive exams, even if you go for the some legal court also, they won't say about this calculators, etc., etc., etc. Why? Because it's happened. Okay, one of the examinations, some students went to the court that how to solve this type of gate questions. Okay, but the court is given some judgment regarding this. Okay, so competitive exams is the best process to eliminate the candidates. That's it. Okay, so if you want to be tough, if you want to be prepared for the job, then you need to ready for this kind of questions also. Okay, so there they will ask the standard questions from the gate exam. That's why I'm giving the gate examination questions in the example problems, so that you can understand the level of competition and toughness. Okay, if you are preparing for that exam also, then you are eligible for the job. Okay, simply you say that, sir, I don't have the calculator, means you are going to lose a job. So keep this point in your mind. So try to focus on the one mark questions of the gate examination or IES examination. So this will be very important for your preparation. Okay, so don't think that calculate they won't ask the calculator based questions. It's wrong. Okay, if you see the previous year questions, for example, take this question itself. So this question is asked in the AP Transco examination. Okay, okay, like that they will ask. If you see the AP Transco 2019 paper, then you will understand how they are asking the questions without calculators. Okay, so be prepared for that, friends. Next one, a transmission line has equal voltages at the two ends, maintained constant by two sources. The third source is to be provided to maintain the constant voltage at the either midpoint of the line or 75% of the distance from the sending end. Okay, then the maximum power transfer capability of the line in the original case and the other cases respectively will be in the following ratios. Okay, see here there is a one transmission line is there. Okay, where we need to maintain a constant voltage here. So for that we are using two voltage sources. Let us assume the 1.0 is a per unit and 1.0 is a per unit you are maintaining. Now there will be a one more voltage source if you are adding. Okay, here in the midpoint. Midpoint means if you consider the entire length is L, the midpoint length is L by 2. Or there is a one more source you are going to install at 0.75 75% of the length from the sending end voltage and receiving end voltage. So here the only parameter that is varying is the length. Remaining voltage is, they said that constant voltage. So constant is 1.0, 1. 0. Okay, so from this, if you take the first case, so P is maximum power, so P max is equal to V square by X here. So V square means actually 1.0, whole square means 1 only, divided by X is nothing but let's say X value. Now second case, as here at this point midpoint, now at the midpoint 2 I can say V square by X, but here the X is going to be what? X is going to be length is divided, so X is proportional to length. Okay, as the length changing here, then so it is 1.0 whole square, it is nothing but X by 2. So this formula is going to be 2.0 divided by X, will get it. And similarly the third case, so third point here, when 0.75, so P3 also we can say V square by 0.75 into X. If you take the all the P1 P2 P3, so this one let's assume that P1, okay, and this will be P2 midpoint, and this will be P3. So P1 is to P2 is to P3, the ratios will become, so it is 1.0 divided by X ratio 1.0 2.0 divided by X, and the third one will be 1 divided by 0.75 into X. If you take the X as a common, the ratio will be 1, 2, and 1 divided by 0.75. So that's why the answer is B is the right answer for this question. So thank you friends, thanks for watching my video. If you like this video, please subscribe to my channel and share with your friends. Have a nice day.